Today we're going to talk about one of the 4 types of FRQs on the AP exam. This one is on modeling a periodic context. So it's a word problem. You'll be given a word problem, and these are very predictable in what they ask you to do. We're going to be applying what we learned transforming, translating sine and cosine trig functions. Okay, this is also called harmonic motion. In the problem, you might be given a picture of a situation. You'll definitely be given details which describe some sort of periodic motion occurring in the situation. Then they will name a function for you. We're going to call it f. Quite likely the independent variable is time, so I'm going to call it f of t, but there is of course a chance that there might be a different kind of situation and the independent variable will be something different. But the time, what I have seen so far, it's always been time. Alright, there are 3 parts A, B, and C. In part A, you will be given this graph exactly, okay? And you'll be asked to name possible points on, for F, G, J, K, and P, possible points. There are many, many different possible points. You're going to name up one set that will fit, that fits for the details given in the problem. In part B, you're going to be asked, using that graph, you're going to be asked to find an equation, either sine or cosine, so be careful, it'll either be a sine or a cosine. You're going to be finding the values of A, B, C, and D that fit the function for that graph. Remember that sine starts at 0, cosine starts at 1, so if it was a cosine curve, I would like to start up here. If it was a sine curve, I will probably be starting back here. So I'll name another point, find the shift, whatever. Okay? Alrighty. The last part, I think, is the easiest part of the 4. They will give you 2 of the points. They'll be consecutive, and they'll ask you what's happening there. So from F to G, the curve is decreasing, right? Decreasing and concave down. So you'll be asked here, are the values positive or are they negative? And are the values increasing or are they decreasing? And then in the next part, it deals with concavity. So if the curve is concave down, you'll say that the rate of change is changing at a decreasing rate. That's for concave down. For concave up, the rate of change is changing at an increasing rate. So part C is by far the easiest of these 3 parts. But I don't think any of the 3 are really that bad. They involve analyzing the situation and coming up with possible points, then finding an equation, and then describing the curve. Okay, let's do a few examples here. In this first one, we have the blades of an electric fan. They're rotating clockwise, and they complete 5 rotations every second. 5 rotations every second. We'll remember that. Okay. Point B is on the tip of one of the fan blades and is located directly above the center at time 0. Okay, so it is up here at time 0. Okay, it's hard to see that yellow. Alright, point B is 6 inches above from the center of the fan, so the radius here is 6 inches. The center of the fan is 20 inches above a level table on which the fan sits. As the fan blades rotate at a constant speed, the distance between B and the surface of the table periodically decreases and increases. Okay, so that was a lot of description, describing the distance, and remember, okay, never mind. The sinusoidal function h models the distance between B and the surface of the table. Between B and the table. So as the fan rotates, the distance goes down, and then the distance increases, and then decreases, then increases, then decreases, and increases. So it's periodic how it does that. All right? Okay. Part A. The graph of h is modeled by this curve. We want to find possible coordinates for these 5 points. So let's think about this. All right. Well, at time 0, where is B? I like to come over here. These are the y coordinates, right? These are the y coordinates. So what is the furthest that B is from the table? Okay. Point B is 6 inches from the center of the fan, and the center of the fan is 20 inches above the table. That means point B is the farthest that it could be is 26 inches. Okay? When it's halfway around, it's level with the center, and that is 20 inches above the surface of the table. And then that means the lowest it could be is 6 inches lower, so 14 inches. Okay, I like to do that first. That gives me the y coordinates of all of these points. Now all we have to do is do the x coordinates. Well, at time 0, remember the x coordinates are time. They're really t coordinates. So at time 0, we are up here. We're the farthest it could be. So I'm going to make F my time 0 point. At time 0, the y coordinate is 26. The h coordinate is 26. Okay? Now I like to go to the end, to one complete period. One complete period. I need the time that it takes to go one complete rotation. The fan goes 5 rotations every second. So 5 rotations every second. So how long does it take to go one rotation? So one rotation every how often? Well, if it goes 5 every second, then one rotation would be 1/5 of a second, right? So the time that it takes to go one rotation is 1/5 of a second. And the y coordinate there is 26. Okay. Down here, I like to come here, so I do find my starting, then I go to the end of one cycle. Now I'm coming halfway between there. What is the time that's halfway between 0 and 1/5 of a second? That would be 1/10 of a second. And we're down here at y equals 14. Now I like to come and do this one, G. What time is halfway between 0 and a tenth? 1/20th. And that y coordinate is 20. And then lastly for K, okay, you can either think of this 2 ways. What time is halfway between a tenth and a fifth? Or we already know that it took a 20th to get to here, another 20th to get to here. It'll be another 20th past that. So 3/20ths. So I'm going to name these. So F has coordinates 0, 26. G has coordinates 1/20, 1/20, 20. J is 1/10, 14. K is 3/20ths, 20. And P is 1/5, 26. Okay? Alright, let's go to part B. Part B. So this is the part where we are now going to name the A, B, C, and D values for the equation of the function. So the equation that they give me has a sine in it. So I need this to be a sine curve. My preference would be a cosine curve, because then I could start here at F and that would be a cosine curve. But they won't let me, they make me do a sine. So I need to do a sine, therefore I'm going to come over here. I have some choices, but what I'm going to do, I prefer to deal with a positive sign rather than a negative sine curve. If I start at G, it would be a negative sine curve. I prefer to start over here. So either way would be fine, but I'm going to come over here and name another point. What point would that be? Well, that point would be, I'm going backwards from 0, so this would be negative 1 over 20, and then the y-coordinate is 20. So that's going to be like my starting point for this sine equation. Okay. So let's see. I'm shifting, since I had 0 here, I'm shifting it to the left 1 over 20. That means that the C value in here is positive 1 over 20. And I need to go up 20. That means D will be positive 20. Okay. Now let's do the amplitude. The amplitude here is 6. That means A is 6. And lastly, the period. The period is 1/5, right? So the period is 1/5. And we know that that is 2 pi over B. I'm looking for B. So 2 pi is the regular period for sine. Divide by B to get the period. So I'm going to cross multiply, and I get that B is 10 pi. So we found that A is 6, B is 10 pi, C is 1 over 20, and D is 20. Alrighty. Okay, now we're going to go on to part C. So now we're referring to the graph of H in part A, and we want to look at point K and point P. Point K and point P. So K and P are here. There's that part of the curve from K to P, and I notice that from K to P my function values are positive, they are increasing, and they are concave down. The curve is concave down. So positive, increasing, concave down. So I note that. Positive, increasing, concave down. Okay, the positive and increasing will be for this part, and the concave down will be for that part. Okay, so the values of H are positive and increasing, so A is our answer there. And for part 2 here, we want to write the rate of change of H is changing at a decreasing rate. That's what we're going to write. The rate of change of H is changing at a decreasing rate, since that part of the curve is concave down. So like I said, part C to me is the easiest of everything. Okay, let's take a look at another problem. Number 2. Okay, the vertical motion of the tip of a needle on a sewing machine is periodic with respect to time. The figure shows the location of the tip of the needle in relation to a cloth plate. The tip of the needle moves up and down, above and below the cloth plate. I don't know if you guys are familiar with what a sewing machine, how it works, but there's the surface of the machine, and the needle goes up, and then it goes down below into the surface of the machine, and then it comes back up, and it just keeps doing that. Alrighty. The maximum displacement of the needle is 2.5 inches at time 0. Okay, and the minimum displacement of the tip of the needle is negative 2.5 centimeters at time 1/24 seconds. Okay, so when we're looking for our points on this curve, I know that my highest y is 2.5, my lowest y is negative 2.5. That means my center is at 0. Okay. Alrighty. At time 0, we are at the maximum. At time 0, once again, we're at the maximum. We're at the minimum at 1/24 seconds. 1/24 seconds. Okay? Which means we're at the maximum at what time? We're at the maximum then in another 1/24 seconds. That would be 1/12 seconds. Okay? So let's come and do G. That's y is 0, but what is the x coordinate? It'll be half of 1/24. So that's 1/48 of a second. And then in another 1/48, so 3/48, we'll be back at 0 here. So that was a quick way to get all those points. So point F, point G, point J, point P, oops, point K, we'll go in order, I guess, and then point P. Alrighty. The function D is in this form. Another sine curve, and that means it's another one where I would have preferred to do cosine. I would have preferred to start up there. Time was 0, that would have been nice, but they won't let me, so I will come and do this one again. So what would that point be? That point would be negative 1/48, 0, right? So that is a shift left. That's going to be my starting point for sine. So left 1/48. That means that C is positive 1/48. We're not shifting up at all, so no vertical shift. So D is 0. I'm writing this for the sake of your notes. You wouldn't have to write that on your paper for the test. Okay, let's do the amplitude. The amplitude here is 2.5. So A is 2.5. And now for the period. So what is the period in this situation? The period to go from high to high, it would be 1/12 of a second. So the period is 1/12 of a second. That's equal to 2 pi over b. We're finding the value of b. Cross multiply again, and we get that b is 24 pi. So a is 2.5, b is 24 pi, c is 1 over 48, and d is 0. Now for the easy peasy ones, let's see where they want us to go. They want us to go from j to k this time, from j to k. From j to k. Well, from j to k, the function values are negative from j to k. The function values are negative, but they're increasing. It's going up. So negative and increasing, and concave up. Negative, increasing, concave up. Negative, increasing, concave up. Negative, increasing, concave up. These two will go to this one. Concave up will go down here. All right, negative and increasing, that is answer choice C. And here, I rewrite this part, and then I'll say at an increasing rate. So, the rate of change of D is changing at an increasing rate. These are so predictable. You just have to remember to write that. You get full credit. Okay, last one here. This one. For this one we have a theme park thrill ride. Involves a tower and a carriage that rapidly moves passengers up and down along a vertical axis as shown in the figure. The carriage is lifted to the top of the tower, then released to move down the tower. The ride involves 10 controlled bounces from the highest point to the lowest point and back to the highest point. A point X is located on the bottom of the carriage, and at time 0, let's get a little pen here, at time 0, X is at its highest point again. Okay, at time 0, X is at its highest point of 120 feet. So I'm going to come down here and start writing. The highest point will be 120 feet. And since that is my time 0, I can go ahead and do that. At time 0, we're at 120 feet. Okay, the lowest point is 20 feet. The lowest point, 20 feet. Okay, the next time that X is at the highest point is at time 8 seconds, which is the end of one bounce. So at 8 seconds, we're back to the top. Okay, what would be this middle? What is that middle? It's the average of 20 and 120. So add them together, divide by 2 to get the average. So that will be 140 over 2, that's 70. Okay, coming back here, the middle spot here, the middle time would be 4:20. That makes G 270, and it makes K 670. Easier to do when we have nice numbers in there, right? I think so. All right. So let's see. F is 120. G is 270. J is 420. P is 120. And K is 670. All right. let's get these values, these A, B, C, D values. For this time, they're going to let me do a cosine. Finally, I was hoping that I would get to, because once again, I'm starting at time 0, we're starting up. So I'm just going to start right here, and that will be a positive cosine curve. Okay? So we have no horizontal shift, no phase shift. Remember, phase is horizontal. No phase shift. So C is 0 this time. But we are shifting up, and we're shifting to the middle. Remember, we're not shifting all the way to 120. We're shifting, the D value is just the middle, right? So we're shifting up 70 to get to the middle. So D is 70. Okay? Amplitude. The amplitude is 50. So A is 50. And the period now. The period is 8, and that is equal to 2 pi over B. Cross multiply, and we get 8B is 2 pi. So B, if you divide by 8, B is pi over 4. So A was 50, B was pi over 4, C is 0, and D is 70. Okay, it is important to note that we could have started elsewhere. In all of these problems, we could have started elsewhere. These are the values that will work to create that curve. Okay? These are the values that would create that curve. But if we had started over here, we would have had different values but create the same curve. Okay? Alright, now for the easy part. Oh, and I can see that one of my pages got cut. Well, shoot. Okay, I need to make sure I get this. Part 2 here got cut off, but we know what it's going to say. Alright, let's see where we're supposed to go. So we're going from F to G this time. F to G, F to G. So we're on this part. The function values are positive. They are decreasing, and the curve is concave down. Positive, decreasing, concave down. Positive, decreasing, concave down. So positive and decreasing, that'll be answer choice B. Concave down. The rate of change is changing at a decreasing rate. Concave down, decreasing rate. Okay, that is it for modeling a periodic context FRQs.